Many people are looking forward to the day when software-defined networking will allow all the configuration to be done automatically on all of our networking devices. It'll be great. Well, until then, and it may be a long time until then, if we want to implement certain features like security policies and network address translation, it's going to be up to you and I to actually implement and verify that it's working. In this nugget, we're going to focus on implementing port address translation. In the nugget titled Configuring a Security Policy, we talked about the idea of a 1-2 punch in order to get this user like Bob access out to the internet. Number one was to set up a security policy, which we did in that respective nugget. The second issue that we need to deal with is some type of network address translation or port address translation to change out the source IP address that's on the 10.1.1 network that Bob is currently using. Now, in my home lab environment, as packets are forwarded out to the internet, there is yet another NAT device that's additionally doing network address translation. So just for the purposes of this lab environment, let's imagine that the 192.168.1, for all intents and purposes, is a globally routable address. So if we train the firewall to do either NAT or PAT using the 192.168.1 as a globally routable address, again, just for our lab pretend purposes, that would be great. And once again, even if we do NAT here to that address space, there's another NAT device taking it once again before it goes out on the live internet. So for the full connectivity, I just want to make sure you had a picture of how all these pieces were working together. So for this demonstration and walkthrough, let's do this. Let's go ahead and use this IP address, the .250 that's already being used on this 1/1 interface, and we'll simply use port address translation to do overload on that existing address. So we'll set up a rule, and simply a NAT rule that's going to say if traffic is sourced from 10.1.1 and it's coming in from the inside and it's being routed out of this outside interface, go ahead and do network address translation on the source IP address to go ahead and use the .250 on the 192.168.1 as the new source IP address as that packet is forwarded out towards the internet. And then when the reply traffic comes back from the server or whatever Bob was accessing, the Palo Alto firewall will remember that translation, do an untranslation, if you will, before it forwards that reply packet back to Bob at his real address on the 10.1.1 subnet. So we begin our configuration journey in the graphical user interface that's currently connected to our firewall. Here we have our dashboards tab, and what we're going to do is we're going to go back to policies. It's under the policies tab and security where we configured our security policy in the nugget titled configuring a security policy. And we're now tasked with making sure we get network address translation also working for Bob and other users on his subnet. So to do that, under the policies tab, we are going to select NAT on the far left. Now there's currently not any network address translation policies in place, so to add a new NAT policy, we'll simply click on Add here in the bottom left-hand corner of this NAT policies page. And once again, we're going to start on the left and work our way right. So let's name this PAT policy for inside to outside, because that's what it's going to do. Now as we consider using this name, the reason that we have this red underline here is because it is too long. I think there's a maximum character of 31 or something. We can actually hover over this. It'll show us. There we go. So the maximum length of this field is 31. So back it up. Now with that name being acceptable, we'll go ahead to the next tab, which is original packet. And we're going to set up another if-then statement. So if the source packet, the original packet, and then we can specify what zone it's coming from. So if we want to say any zone, we can, or if we want to specify a specific zone, we can go ahead and select it. In our case, we want to identify and translate the source IP address based on traffic that's coming in on the inside. And regarding that original packet, we're on the original packet tab, if that packet is trying to be routed out of the destination zone called outside, and we can further specify what specific interface, because we might have 2 or 3 or more interfaces that are all part of the outside zone. So we'll select Ethernet 1/1. In our case, that's the only interface that's part of the outside zone. We can also lock it down for that network address translation to only occur based on a specific service. In the case of our users, based on the security policy, they're only going to have the ability, permission-wise, to actually get through if they're using SSL or web-based services or DNS. So for here, I'm going to leave the service as any. And then over here, we can lock it down based on the original source address or destination address in that original packet. So let's be even more granular. Let's go ahead and say we want to add the source address, and we're going to use that address object once again, the 10.1.1, which represents anybody whose source IP address is coming from the 10.1.1 subnet. And then regarding the destination address, they could be going anywhere. So in our example, we're not going to restrict the network address translation based on the packet going to a specific destination, which means it could go to any IP address on the outside. As long as the packet is being sourced from the inside, being routed out the outside, and going out specifically interface 1/1 and the inside source IP address is 10.1.1, if all those conditions are met, we can go ahead and do a translation action on this packet. And the translation action is going to be specified in this next tab, which we're going to go to right now. So we'll click on translated packet, and then we can specify what we want to happen to that packet. And when I say to that packet, I mean to the packet that matched all those previous criteria that we specified on the original packet tab. So for the translated packet, we're going to go ahead and do in our example, we're going to do dynamic IP import, which is effectively PAT. Or in some vendors, they call it overload, where we're going to map multiple IP addresses over to a single IP address. And that could include hundreds or even thousands of IP addresses. So we're going to select dynamic IP import, and now we have to specify what IP we're going to translate to. So for the address type, we're going to go ahead and we're going to say the interface address of the firewall. Now we could also say translate address and add a specific IP address, for example, from the 192.168.1 subnet. But since the firewall already has a beautiful IP address of .250 on that outside interface, let's just go ahead and use that IP address. So we'll select the interface address, and then from the drop down, we'll specify the interface, and then furthermore, we'll go ahead and pick the only IP address on that interface, which is the .250. And if all that looks like it's in order, we'll click on OK. Now there's one last step that we really ought to do, in addition to just reviewing the details that we put in, and that is to do what? And if you're saying, Keith, I know, we need to commit this, you'd be absolutely correct. So we're going to click on commit, click on OK, and then we're going to go ahead and verify whether or not the combination of NAT rules and the security policy allow Bob the user to use DNS and web and SSL services as he goes out to the internet. Now to test this, we need some type of a client here on the 10.1.1 network. Now thanks to VMware Workstation, we can go ahead and simply place a computer on that 10.1.1 network. And just as a reminder, inside of VMware Workstation, that is logically associated with VMnet 1. So if we have a virtual machine and we associate the network interface card with VMnet 1, it'll be on this broadcast domain, on this layer 2 domain. And then we can statically configure an IP address on that PC, tell it the default gateway is 10.1.1.250, and also configure it to use a DNS server, either a local one or an internet-based one. And if everything's working correctly as configured, which would include our security policy as well as the network address translation policy that we just configured, this user should be able to get out to the internet and successfully get responses back for SSL, HTTP, and for DNS. So it just so happens that in my VMware environment, I have a Windows 10 machine that I've been playing with. And let's take a look at the details for this Windows 10 machine just to verify it's connected to the right logical VM network. So we'll right click on this virtual machine. We'll go down to settings, and there's our network adapter, and it's currently associated with VMnet 1. So it's in the correct virtual network. And all we need to do is make sure we have a valid IP address on it. Also, one of the features I like to use quite a bit is enabling VNC for remote access to a virtual machine. That way I can get access to it and move it around if I need to without having to use the console function of VMware Workstation. So to set that up, if you want to do that as well, under the options for this virtual machine, there's an option for VNC connections, and I just clicked on the little box that says please enable it. So then I can use a VNC client, connect to that host on that port, and automatically get connectivity to that virtual machine. So if you want to use that little trick, you can. It just makes it a little bit more convenient, and that's why I'm sharing it with you as well. So everything looks good here. I'm going to click on cancel. I'm going to go ahead and minimize this application, and let's bring in that VNC session that's doing a remote control session with that virtual machine. So this represents the PC that's sitting on the 10.1.1 network. Let's do a quick check of its IP address. We'll bring up a command prompt and do an IP config. That's not good. So let's fix it. Let's see here. This is a 169 address. That's the automatic private IP addressing assignment, which basically implies that it's very likely that this is a DHCP client and there's no DHCP server handing out IP addresses on that subnet. Or in our case, that'd be VMnet 1. So let's just statically assign this guy an IP address. So we'll go down to the icon in the bottom right hand corner, right click, select Open Network and Sharing Center. We'll click on Change Adapter Settings, right click on the Ethernet adapter, and go to Properties. From here, we'll scroll down. We'll double click on IPv4. That opens up the properties of IPv4, and we'll simply tell it to use the IP address of 10.1.1. And let's use 25. That's available. And we'll put in a 24-bit mask as well. So that's how you spell 24 in dotted decimal, and a default gateway of 10.1.1.250, which is the IP address of the inside interface, the 1/2 interface on the Palo Alto firewall. And let's go ahead and use a Google DNS server of 8.8.8.8, and we'll click on OK. Click on OK again, and then we'll close our control panel dialogues. So now, if we do a up arrow here and do an IP config, there's the information we configured. Let's go ahead and do a real quick check. Now, from the command prompt, we can't ping because our security policy doesn't allow ping through. But what we could do is this. Let's do a ping of www.google.com, and what should work is name resolution, and it is, which basically also verifies that our translation is working. If we could resolve google.com to this IP address using the DNS server at 8.8.8.8, that's out on the internet. That means we have successful connectivity. We could also use NSLOOKUP, so we'll type in NSLOOKUP, and let's resolve www.cisco.com, press enter, and we've got some resolutions, including an IPv4 resolution. We've got a couple of IPv6 resolutions, and also some aliases that came back. And the reason we got all this information, or could get it, is because DNS services, UDP port 53, are being allowed through the firewall. So let's open up a browser. We'll go ahead and launch Chrome, and let's go to cbtnuggets.com. That's working. And let's also go to cisco.com, and that seems like that's working. And let's go ahead and connect via HTTPS. What would be a good option for that? How about PayPal? We'll go to https:// www.paypal.com. That's very likely going to be HTTPS. And that is working as well. Look at that. All right, so HTTPS, there's the certificate information. It's using TLS version 1.2. Fantastic. So I just want to verify that DNS, HTTP, and SSL are all truly working as they're supposed to because of our security policy in combination with the translation that's allowing this IP address to be translated on its way out. In this nugget, we've added a network address translation policy, specifically with port address translation, that gave the inside users on the 10.1.1 subnet, if they're forwarding traffic out to the internet and going from the inside zone to the outside zone, our NAT policy caused the source IP address to be translated to the 1/1 outside interface address that's currently on the Palo Alto. And your homework assignment, my friend, is to lab up and practice. Everything that you see us do in these nuggets, I'd like you to practice on your own. And that hands-on practice will help you and serve you anytime you're dealing with, monitoring, or troubleshooting a Palo Alto firewall, because you'll have the hands-on practice beforehand that's got you ready. So have fun in the lab, practice, practice, practice. I look forward to seeing you in the next nugget. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.